Hello everyone. In this video we're going to be going through problem 206, which is reverse linked list. So this problem states, given the head of a singly linked list, reverse the list and return the reverse list. So we have 1, 2, 3, 4, 5. It's going to return 5, 4, 3, 2, 1. Example 2, 1, 2 returns 2, 1. And example 3, an empty set will return an empty set. Pretty straightforward. So how we're going to code this is we're going to first define a list node called previous node and assign that to null. And then we're going to assign another list node called next node equal to null as well. So this is basically just going to keep track of the previous nodes and the next nodes. So while the head is not equal null, we're going to assign the next node equal to head next. So if we use the example 1, it was 1, 2, 3, 4, 5. So head is 1 and head next is 2. So then we're going to assign the head next equal to the previous node. So the first time through, this is just going to be head next will be null. And this will make a little more sense as we go through the debugger. And then the previous node is going to be the head. So the first time through, previous node will be equal to 1. And then we just assign the head equal to the next node. So let's run through this real quick. So the first time through it's 1, and then down here next node becomes 2. So now the head is 2 and the next node is 3. So now head next is the previous node. So head next is 1 from the previous loop. And therefore when you assign it to the previous node, it'll be 2, but it'll have the 1 attached to it. And this will just keep going through attaching the previous node to the head, so it basically builds the list backwards. And you'll see it in the debugger. And at the very end, we'll return the previous node. All right, so let's debug this. So using that first example, we go through. So previous node is null, next node is null. So head, well, head is not equal to null. Next node equals head next. So next node is going to be equal to 2. So head.next is previous node, which is null. And previous node equals head. So now previous node is just equal to 1. And then we'll assign the head equal to next node, which would be 2. So now head is 2. And the next node, so now this will be 3. Now head next equals the previous node. So previous node was 1. So the head next is 1. And then we assign previous node equal to head. So this will be 2 and with the next value of 1. So that's why we append head next equal to the previous node, because we need to capture that 1. And then we go through this again. So head is 3. Previous node is, previous node is 2. So head next is 2. And then we'll assign the head equal to the previous node. So you should see that that is now, 3. And we appended head next, which was 2, but head next, or 2 had the value 1 from the previous loop. And so just keep going through this. Head next equals, what is it? Head next equals, okay, head 5. So this head is equal to 4. Head next is 3, so now previous node equals head. Value 4, 3, 2, 1, and so forth. You can see how it's building the list backwards. And finally, we'll go through 5. Head next is null. We assign head next equal to the 4 from the previous loop, and then assign everything to previous node, the head to previous node. Head node next is null, and so it returns previous node. So if you look here, we've got 5, 4, 3, 2, 1, which is the answer. All right, let's run this through LeetCode. Accepted, submit it, and faster than 100%, and uses less memory than 99.44, so very efficient solution. Let's finally go through the time and space complexity. Time complexity is O of n, so as we increase the amount of nodes in the linked list, it's going to take longer. And then the space complexity is O of 1. Once we pass in the linked list, we're just reversing it. We're not adding anything. We're not deleting anything. So O of 1 is the space complexity. And that's it. So thanks again for watching. Let me know if you have questions, and we'll see you next time.